So we left the last video at a situation where we have an exception being thrown because the child class, which was derived from this concrete car class, was not basically implementing one of the functions of the concrete car class, and the concrete car class function didn't have full implementation, so there was no indication that our child class has missed out this implementation at compile time, and at runtime the user is seeing an exception, which is not a very good scenario, especially in a production environment. So is there a way that our compiler can tell that there is a function in the base class which is not being implemented fully in the base class, and also has a missing implementation in the child class? And to answer this question, we have to look at the abstract classes. So we have an abstract car class which is pretty similar to the concrete car class. It has got an automatic property, a similar kind of constructor, public constructor. The apply break is absolutely similar, but if you can see, it has an accelerate function, again not defined at all, but also highlighting this abstract keyword, and because we have got an abstract function, these kind of functions are called abstract functions, and because we've got an abstract function inside this class, therefore we have to highlight an abstract keyword at the class, indicating that this is an abstract class, it has got abstract functions. And because this class is an abstract class, we cannot create an instance of this class because it has functions or methods which are abstract and doesn't have any implementation whatsoever at all. To demonstrate the abstract class behavior, we have created another class which is called a blue car class, and blue car class is derived from abstract car, and the implementation of blue car is pretty similar to what we have in the red car class. So we have an accelerate function within the blue car function, and it is basically increasing the speed of the car by 3. So that is the blue car class. Now what I'll do is that I'll go back into the red car class and uncomment this so that we don't see the exception when we execute it the next time. Just put it out of the debug mode, and I'll go back to the program car class, and what I'll do is that I will basically uncomment this section of the program, and what it will do is that it will show us the blue car implementation. So we can see blue car speed. We can create it. So we are creating a blue car instance with an initial speed of 15. We are checking the speed straight away, and then we are applying brake, and then we are accelerating, and what we are expecting to get as an output is something like this. So this is the red car implementation, and this is the blue car implementation. So you can see the initial speed is 15. After applying brakes, the speed is reduced to 5, and because in the blue car implementation of accelerate function, we were increasing the speed by 3 times once accelerated, so we can see 15 over here. But to highlight the difference which I mentioned before, what we'll have to do is that we'll have to comment out the implementation of accelerate function from the blue car. And remember, the base class in this case, which is an abstract car class, is not implementing accelerate function. This function, the accelerate function over here, is just an abstract function. So let's see if we have the same kind of exception in this scenario. And for this, I first have to compile the solution. And if I compile the solution, what I'll see is that it is complaining, and what it is saying is that blue car does not implement inherited member, which is accelerate. So you can see that in the case of blue car, as soon as we commented out this accelerate function, it didn't run the program entirely. It didn't throw any runtime exceptions. Rather, it basically raised this issue at the compile time, and this is a much more preferable outcome, because we want to see these kind of missing implementations at compile time stage rather than runtime stage. So the only downside of having an abstract class is that you cannot create an instance of an abstract class which you were able to create in a scenario of concrete car class, but when you go down a level and you try to create the child class of concrete car class and child car of abstract car class, you can definitely see the advantage of abstract class, where a missing implementation in the child class is basically raised, being raised as a compile time error in during the compilation stage. So in the next video, I'll try to address what interfaces are and how they are different to abstract class.